All right, so finally back to testing Axiom, finally up to full voltage. Had to sort out a few problems with things related to chip shortages and a couple little things we wanted to change to help with noise in the resolver circuit. Um, this can run most permanent magnet EV motors. Right now we're up to 465-ish volts, basically. What we have set up here is this here is the drive side, which will be measuring things on that plot, and this will be the regen side. So this will be set up to run, try to achieve an RPM. I'll probably do an RPM sweep on this side, and this side will be the side that I apply the throttle here. Right now I have the drive set up with 605 phase amps. I'll bump that up a bit once I'm ready to go a little further in power. We have 3 Axioms sold already. We just basically want to make sure these are good, so I want to do a bit of testing and get them out the door. I've been testing on these for a few months now, probably 6 months or something like that, on these actual Axioms with the enclosure and everything, maybe even longer than that, but thorough testing at higher power outputs. I have some good cooling set up, a couple radiators on the back, cooling the motors and controllers separately, so each side is separate. And then basically from there, once I prove the power I want to prove and things seem to run pretty decent, we will order our next batch of enclosures and all the components to build up some more and get them out the door as well. So hopefully this year we'll be able to start putting them in the Honda CRX. It'll come together pretty quick once I finish testing. The main thing holding up the CRX is actually making sure we have Axiom running at full power, and then down the road we'll have some other surprises come with all that stuff. So let's get this up and going here. So these little squirrel cage fans, these little air movers, they work really good. So we will make sure we're recording the screen too. Get some good testing going here. So this will be the first test at this voltage at 465 volts basically. So we'll get it spinning. So right now this side's trying to spin basically and hold it at roughly 2000 electrical RPM. And then this side, oh shit, I just realized something. I gotta look at something here. So before I go any further, I actually need to stop this, and I need to invert the motor direction on this side. Somehow that got swapped, and I'm not sure why that is, but we'll just do this. So save that, save that. I want to double check now that I see that problem, I want to double check the encoder alignment, because sometimes it's an encoder alignment thing. Yeah, somehow I ended up with the wrong encoder alignment saved on this side, so I need to stop everything right now. All right, so back to recording. I just did a encoder offset detection. Sometimes what happens is because I got two instances of the same two instances of VESC tool running on my computer, on the same computer. This way we can screen record and record power in, power out. I'm trying to be as accurate as possible and record it in real time, so it's a lot more accurate on like our losses and everything. What happens is once in a while I open the wrong one on the wrong side and then accidentally click save and save the configuration for the wrong side. So need to always keep an eye on the RPM and make sure it's reading the correct direction. So this will be the first time I've run a load at this voltage with the enclosure. Now, like we showed a couple years ago, we did test full power with Axiom. So it's up and spinning right now. You can see it's a bit of a mess under here, but you can see the rotor spinning. So should be able to start applying power here. So there's 40 kilowatts in, 30 something kilowatts out. We can probably bump the RPM a bit to get more kilowatts. There's 58 kilowatts in. 62 kilowatts in, 43 out. So I think it's pretty safe to go do a proper run. 70 kilowatts in, 60 kilowatts out. So now what we'll do is we'll try to do a proper RPM sweep. So with this setting here, what we like to do is probably should be able to do 12. Let's hope for 12 to work smoothly and safely. Keep RPM. I want to do point. I can't remember how fast, but 0.04 should be good. Maybe I'll do 25 RPM per step. Won't start at 0. I'll start at like maybe 3,000 electrical RPM. Now we've got keep RPM, so that's all good. So one thing I'd like to do is I like to, in case there's any faults, I like to have this sample when the fault happens. Trigger at fault codes. Trigger sampling at fault codes. So I want to make sure that's ready. And then we'll go back here to real time, make sure we're watching current, probably one of the most important parts of the screen. Make sure this is ready to watch current as well. And then basically, so what I'm going to do here is I'm actually going to probably set the phone down so it can record from afar. And see if this will work. Maybe I can put this, I should actually have the phone set up with a tripod, but I gotta find my tripod. Kind of in a hurry today, just want to get a bit of testing done. So what I'll do is I'm gonna run this side with my left hand. I'm actually right-handed on the mouse, but this will let me get this side going. That run right there broke 100 kilowatts. Everything looked pretty good. Pretty happy with that. So we'll go back here and look at the experiments plot. You can see we had a nice clean run right up to it's like 108, 109 kilowatts. It wasn't quite 110, maybe 107 peak, but or that was on the input side. So the output side is actually less. So let's see, 10, 20, 30, 40. So it's probably 20, 40, 60, 80, 100. So 20, 40, 60, 80. It's like not quite 90 kilowatts on the output, but a nice, clean, smooth, really good looking run. Pretty happy with that. So now what I think I'll do is, again, like I said, this is only with 605 phase amps on the input side. So we can always up the current, maybe go to 7 and just test it with a bit more power, do the same run again, make sure the current on the output side is set to be able to accept that, so we should be okay. And then basically have a look at everything. We don't see any high temperatures or anything, and everything looks good. We're down 5 volts, 4 volts, whatever, not a big deal, enough that we can do a pretty safe run. So I'll set the phone down and do another test just like that. Go this way. I should have my phone the other way so I can actually let's see. there because she was starting to rip, and I believe that's a field weakening thing. I gotta have a look, but you can see it just started ramping up. If we look at the RPM, it just started taking off, and I didn't want to have a fault because sometimes when that happens, spider on my desk here. Get rid of that guy. Don't need him biting me while I'm doing this. I don't know if anybody remembers my video, but I got a good spider bite on my arm from a brown recluse about a year ago, and it made me sick for a while. It's actually worse than COVID. Nonetheless, that was some legit power there. So let's go have a look at our experiments plot. I think what it is field weakening ramped in a little bit hard there at the end, and I'll have to work the tune field weakening in. It made a big difference going to, I believe, yeah, it's only 705 phase amps, but it made a big difference. So nonetheless, there's some tuning to probably be had there, but you can see we did, 120, 140, basically peaked like 150 kilowatts out. So not a continuous power rating, but believe it or not, the continuous power rating is up there quite a ways. The IGBTs hit maybe 45 degrees Celsius on the dry side, and if you look at the regen side, not even 40 degrees. So I've done some pretty good testing with this, and basically I will do a continuous power rating test at some point, but right now I'm just trying to prove some power output from this. I have to look at why it's ramping in field weakening like that. So let's come back over here and have a look at field weakening. I've got it set for 350 field weakening amps. Probably bring that down, and I might bring that right down actually to like maybe 50, and just try another run to see if this can control things properly. And then the other thing is we got maximum torque per amp, which you want to make sure the maximum torque per amp is set good to begin with. And that's in the general here. We basically the inductance difference, and we found that worked really good there. So I think there's I have to go back and read my notes. It's been a while, but I have to go back and read my notes and remember what's going on with the when the field weakening ramps in like that. I remember it was related to the combination of maximum torque per amp and the field weakening, but also some of these settings like the duty start for field weakening. And so there might be some tweaks there. So let's just go back here though, and do this test again with only 50. Let's make sure that I've saved that 50 amps field weakening current, and let's just make sure that it's gonna work there. I'm actually going to just keep recording, and we're still at 461 volts, so not bad. Temperature's sitting at 20 degrees on the dry side and basically 20 on the regen side, so those cooling fans and radiators and everything are working really good. These are fairly short runs, but like I said, it'll do quite a bit of power continuous as well. So, come back here. Here like this. Get it started. Get an over voltage fault there, but it's actually when I let off the throttle. Oh, I meant to pause this. Damn, catch it in time. Yeah, the RPM ramped in pretty good right at the end, but it still seems to be a field weakening thing, the D-axis current. So if I come back here and look at FOC, see, damn, I caught it a little bit too much towards the end, but the field weakening current probably ramped in a little bit too far, too fast. At the end, so we'll have to look at that. There might be some settings I have to change. The power is definitely there. Like I said, I've ran this before to 800 and plus phase amps, and with this power, right now we're doing really good. Let's go back in here and look at our experiments plot. again, you know, 140 peak kilowatts. It kind of seems, you can see it ramped in a little bit. So the over voltage fault happened as I let off the throttle. And I think it's just because sometimes there's the way the regen side's trying to control speed and the drive side's trying to control torque input. When you let off the torque throttle really quick, the speed control on the PID loops on the regen side does waver around a little bit and causes a fault once in a while. And it is a bit of a tricky game to play. I'm sure we could spend some time tuning the PID loops better, but I've got hundreds of hours playing with that and not a lot of success making it better than it is right now. So let's go back here and look at I would like to, what do I want to do? So we did good there. Everything seems to be running good. Temperature, not quite 40. Temperature, again, 45. RPM ramped in. I want to stop that a little quicker on the next time. Oh, duty cycle. So on the main screen here, typically you can see duty cycle. This duty cycle thing, I don't really understand. Duty cycle is supposed to be the green one, and I don't fully understand it. Try and make my screen level. Kind of OCD just there. I don't understand why it pulses or spikes back to, I guess, negative duty cycle, and there's some sort of error in the code, and I don't know if that's related to our what's going on here, but what would this be? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So yeah, right around 90%. So one thing we can look at is how field weakening ramps in. And I think if I remember correctly, the field weakening duty start plays a role. It plays a big role with where, like with how strong the field weakening comes in. And that's something to consider as well. So I don't want to ramp too much in, but I do want to prove a little more power. So I think maybe we'll go to like 100 here and just see what we see when we get there. And let's go back here to this side and just double check. Yeah, it's set to do 350 on this side. So let's just see what happens with that. So we'll go back here, let it play. So we're back to 20 degrees. Basically everything's cooled back off to room temperature. The shop is roughly, the shop is roughly 18 degrees right now. I haven't measured it for a while, but I want to keep the camera rolling anyway. So we're back at 460 volts. We're doing good there. Let's just get the camera set up. So make sure this is saved. See if this will handle it. It's actually it actually wasn't even really completely done its run yet. It's trying to control the dry side is overpowering the regen side by a fair bit, and it's not because the regen side doesn't have the current capability. It's set to be able to do more regen current by a substantial amount, but the problem is that's actually I don't believe we were over on battery current. We should double check that. Shouldn't be over on battery current. So what is our main DC current in? So basically we're definitely not anywhere as close to our limit on battery current. Battery current's allowed 625 regen. So basically we're hitting 325 roughly. Experiments plot where you basically flattened out right at just above 140 regen, and the input side kind of the same thing. Let's have a look at, now that we got our plot, you can see something funny is going on. So I'll have to probably spend a bit of time tuning this and discussing with the team about maybe making a change to the code, because the D-axis current ramps in, stays pretty flat, and this area here would be maximum torque per amp, but it should actually increase here, and it shows that it's decreasing, and this should be the area where field weakening is. And you can kind of see it ramps in a little bit right there. That's where field weakening is. And I don't fully understand this, why it's showing it to be less D current, but it shows more D voltage. I'm trying to understand that part. If we go to the same plot on this side, you can kind of see, we want to look at this plot with the FOC. Yeah, so it's showing D-axis current ramping back to 0, or actually staying flat here, and then it ramps back to 0 after I let go of the throttle. Nonetheless, power is good. We're doing really good on power. Should probably stop the video there. And I'm gonna actually discuss this with the team before we go any further. This is gonna be a bit of a longer video. Everything looks really good, very promising. Power, I'm not at all concerned with power. I just wanted to let that play for a second and see what the temperature is. So the temperature is back down. You know, if we look at the temperature right here, again, the IGBT's got a little above 45 degrees Celsius, but they're cooling right back off to 20 degrees right after the run. It'll do above 100 kilowatts continuous with good cooling, and that's what we're going to prove eventually. We rated it at 100 kilowatts, and so we want to make sure that everybody is happy with it, but this is definitely going to be a very powerful setup and very reliable too, once we sort out all the little details like getting field weakening to work correctly. So I'm going to stop the video for there, and stay tuned, because over the next few days I hope to get this field weakening D-axis current stuff sorted out so that it ramps in nice and smooth. I can't remember what I had to do with that. I'm going to go over my notes here after I stop the video, and from there, stay tuned. Like, we're, you know, over 150 kilowatts already and haven't cranked the current all the way up. I haven't even cranked field weakening all the way up, so there's a lot more power to be had, and I should not be unrealistic to be back above 200 kilowatts within a few days, where we left off a couple of years ago before COVID and all that stuff sort of set us back a whole bunch. Or